Okay, this is about eclipses, and as I mentioned in my moon's phases video, the way the moon orbits is around the center of the Earth, and for the most part, it's either above the Earth, the Earth's shadow or Earth's orbital plane, or below. So when the moon orbits, it usually does this, and in doing so, it avoids the Earth's shadow, respectively its shadow. If you want to film over there, there's the moon's shadow. So no solar eclipse. When I go to the other side here, okay, this is where it becomes a little tricky. I think you actually can see that. Yeah, it'll work. That the Earth's shadow is above the moon. So here we get actually just a full moon and no eclipse. The Earth orbits around the sun, and I'm not going to show that. I'm not going to simulate that. I'm just going to leave it here. And the moon keeps orbiting like that, but because as the Earth orbits, those orbits relative to each other become in such a way that at some point the crossing point is actually in front of the Earth, and then over here it's below, next to the Earth, and then back here it's also in line with the sun and the Earth, and then up here it's too high. As I said, this happens only every 6 orbits, roughly every half year. So as the moon orbits, I get it exactly in between, and now the shadow of the moon is on the Earth, and that's actually when I get an eclipse, and my shadow is way too big here, but you know, in my scale model I can't do it any better. Actually the actual shadow, the total eclipse, is only very little, a few, I want to say like 10 miles across. There is actually a bigger shadow, we call it the penumbra, and that one you get a partial eclipse. So you can still see some of the sun, and you wouldn't actually notice that there is an eclipse because it's still bright enough. But you have that little point that goes across here, across the Earth, that gives you then the total eclipse. The Earth rotates at the same time a little bit, so it kind of is all dynamic here, and it depends on where you are. I guess the way I put it right here is kind of, that's the Pacific Ocean, you know. Unless it goes right across Hawaii, nobody is going to see it unless you're on a cruise ship. And there are actually cruise ship eclipses. Pay extra few bucks to watch an eclipse from a cruise ship. Then I come over here, and here again it orbits too low, but as far as my eclipse month is concerned, every 6 months, that doesn't matter. And then it comes back up here, and now under normal circumstances I get a nice full moon here, and I do that night and the night before and the night after. But here for a few hours it enters into the Earth's shadow, and now we could have a full a total lunar eclipse, or perhaps a partial eclipse. Could look something like that it's eclipsed here and you still get some of the bright moon up there, and then it re-enters back into the full moon phase. But let's assume that we have a totally lunar eclipse here, and so what is actually the full moon right now, because it's on the other side, is being eclipsed by the Earth's shadow, and everybody who's on the night side of the Earth would be able to see that, because everybody over here is able to look at the eclipsed moon. And it depends on just, you know, if you're on this side here, it's just as you enter night, so you only get to see it very low on the horizon, and on the other side the same, you're exiting night, so you're also going to see it very low on the horizon. The best viewers are up here where they see the moon high in the sky and have a nice eclipse. And then it keeps orbiting, and then on the next orbit, usually now it actually starts orbiting either too high or too low, and we don't get an eclipse. There could be exceptions. Occasionally there is an exception. But what I described here is I get a solar eclipse, and then 2 weeks later actually I get a lunar eclipse. If you look at tables, you will always find that lunar eclipses and solar eclipses are 2 weeks apart. Not necessarily that this comes first and this one, could be the other way around. And overall I think that's what I need to explain about eclipses. Thank you.